Okay, I'm gonna get, does this microphone work? Are we all set up? Or no? Are we all set up? Can you hear me through the microphone? Okay, great, because I'm gonna get started then. My name is Dan Gunders, and I'm a survey methodologist at the Survey and Data Management Core at the Dana-Farber Harvard Cancer Center, and I also am part of the Research Design and Analysis Core in the U54 partnership. And I'm going to talk about using web panels and secondary survey data for cancer research. And I'm going to give an overview of sort of an introduction of what are national or subnational secondary surveys. Most of the big health surveys are national surveys, so I'm going to use those as examples. But there are many subnational surveys, like state-level surveys and regional surveys as well. And then I'm going to talk about what survey panels are. And if there's time, I'm going to go through an example of the National Health Interview Survey. Not so much to show you an analysis of it, but to show you sort of how you might go through the documentation and try to find the right information you need to be able to do your analysis. And it's going to be a fairly high-level discussion, partly because we only have an hour today, but also because you can use these surveys for so many different purposes that what is a statistical challenge or consideration for one application is not a concern for another application. So it'd have to be a much longer presentation to cover most applications of it. So I'm going to focus mostly on how you would approach this if you were going to use the data essentially to generate population estimates at the national level or at the state level. Or more generally use it for the purpose that the surveys were created to do. And there's other uses you can use for it, for grant writing and for other types of analysis. But I'm going to try to keep it short and focused on that. So what are national surveys or secondary surveys? A secondary survey is basically any survey data that has already been collected for some purpose other than yours. Or even more generally, if it's been collected for this, if you're going to use the data to analyze the data for the purpose that it was collected for, it was not collected by you. It's collected by another researcher or another organization for some specific purpose, and you're using it for your own purpose. And there's quite a few national and subnational secondary surveys, and they're collected by a number of state and federal agencies. The biggest ones are probably collected by the census. We also have a number of ones that are collected by the Centers for Disease Control, as well as the various state departments of health. And they're designed to collect and gather data to serve one or more data needs for whoever the sponsoring agency is. So for example, the census needs to produce labor estimates for monitoring economic activity and economic indicators, and they also collect a lot of demographic data. And of course they do the census every 10 years, but they also do a lot of annual surveys. One of the more famous one is the current population survey, where they get labor participation data, like the unemployment rate and those kinds of stuff. And that has tons of naturally occupational data, tons of demographic data, but it also has some health information through various supplements that they do every few years. And one of those is called the tobacco use supplement to the current population survey, which collects a number of tobacco use data, the types of tobacco people use, how often they try or how they go about trying to stop using tobacco, if they're trying to stop, interventions they've experienced in healthcare settings, and that kind of a thing. CDC needs to collect a lot of data on various health behaviors and conditions at the population level, and likewise state agencies collect similar data to meet their needs. Common to these surveys at the national level and at the state level is that They're very, by design, pretty broad in focus. And a lot of these surveys are produced or are designed to collect indicators to monitor progress towards the Healthy People 2020 objectives. And there's a lot of objectives. There's about 1,300 objectives across 40 or so focus areas. And so you can see that you can't design just one survey to measure health indicators on so many objectives across so many focus areas. So you need a lot of different surveys that reach different types of populations for different types of health indicators. So I'm going to talk about two more well-known national surveys, health surveys. The first one is the National Health Interview Survey, which is an annual household survey of about 35,000 households, which yields a total number of interviews of about 80,000, or a little over 80,000 total interviews. So so everyone in the household above, I think, above the age of 5, they gather data on. And they have the Cancer Control Supplement, where they collect information on screening behaviors, diet and nutrition that are related to cancer, physical activity, sun protection behavior, family history, genetic testing, and a number of other cancer-related behaviors and risk factors, as well as some treatments as well. But it has rotating content, and so not all of these, data are not collected on all of these domains every year. One year you might collect on diet and nutrition and sun protection. The next year it might be tobacco use and genetic testing. And the next year after that it might be cancer risk and family history. Another famous or well-known national survey that collects data related to cancer risk is the Behavioral Risk Factor Surveillance System, or what people tend to refer to as the BRIFIS. Excuse me. That's a little different in the design. It's a telephone survey rather than a household survey, and it conducts about 30 to 40,000 interviews per month nationally. And it's sponsored and supported by the CDC, but it's actually conducted by the states. And it does, as the name suggests, collect data on behavioral risk factors. So tobacco use and cessations, whether or not they go for cancer screenings, whether they've been screened for tobacco use in healthcare settings, and those kinds of a thing. It has core survey content that's collected by all of the states. But each state can also select various modules where there's subfoci, which may or may not be related to cancer. So one of the issues you have there is that even if you do want to produce cancer-related estimates at a national level, it might not be available for all states. It might just be available for a sub number of states. So given how many surveys there are, there's also many different ways that the data are collected. The most common ones are in-person interviews, where an actual interviewer goes to somebody's house to interview them. There's also in-home self-administered, where they fill out on a paper or pencil survey, or they fill out an electronic survey by themselves at home. And then there's, like the BRIFIS, interviewer-mediated telephone interview, where a live interviewer calls them, asks them to participate in the survey, and asks the questions that they're collecting data on. Or they can have a mixed mode approach, where there's a combination of some of these or sometimes all of these. So data collection follows, relatively standard procedures in the survey methodology, even though it can do a multi-mode, which is increasingly becoming the standard. But the actual process of sampling and selecting respondents to invite to participate in the survey is typically quite a complex design and a complex process. And that's where sort of the complexities come in when on the user side, when you're going to download the data, merge the data, and particularly analyze the data to be able to produce accurate estimates of both point and variance estimates. And the reason it's complex is because general population surveys, when you're talking about the entire entire U.S. population, or if you're talking about the population of Massachusetts or even Boston, there's no list of people that sort of reside in the U.S. You can't get a list of all people in the U.S. And so you have to design some alternative ways of selecting what you believe to be a random sample or a sample with some known probability of being selection. And typically that takes the form of some multi-stage process. And often we end up with what's called an unequal probability sampling design, which I'm going to elaborate a bit in a moment. But I want to highlight two approaches that are quite common, either by themselves or in combination with some other process. One is called cluster sampling, where you can't get a list of people that's part of your population. You can't enumerate your entire population to draw a sample from. But you can identify some higher level unit that they're a part of, what we typically call a primary sampling unit. That can be clinics that cancer patients go to. It could be primary care clinics in a particular state, or it can be a geographic area. And once you enumerate the higher level units, you can randomly select a subset of those primary sampling units. And then within those primary units, you hopefully are able to enumerate the population members as part of it. And then you do your more traditional random selection within those higher level sampling units. And what this leads to is a nested data structure where you have respondents nested within a higher level unit. And if you work in experimental design or clinical trials, this is the same concept as a cluster randomized trial, except that you're just sampling clusters to reach your survey respondents instead of randomizing clusters to different treatment conditions. But it's the same statistical issue that you have to account for correlation of people within some higher level unit. And in national surveys, very, very often we're talking about geographic units, where statisticians will literally take a map, a list of counties or some other smaller geographic unit, and divide them into smaller subsets that make sense for their application. And then they'll sample from among those geographic areas. And then often within those geographic areas that are sampled, they'll take an even closer look at the maps and the composition of the population and sample neighborhoods. And then they'll send field interviewers into those neighborhoods to start inviting people that live there to participate in the survey. So here you actually have 2 levels of sampling, possibly 3 levels of sampling, where you're first sampling, say, counties and large cities. Then you're sampling neighborhoods, and then either you're interviewing everybody who lives in selected neighborhoods, or you're doing another round of sampling within those neighborhoods. Another fairly common data collection and sampling approach for national surveys and state-level surveys that collect health information are what's called random digit dialing, or RDD for short. And literally what you do is you design an algorithm that randomly dials telephone numbers, and then you have a telephone interviewer who will typically read a script, a standardized script, where they explain the purpose of the survey and invite people who answer the phone to participate if they meet the inclusion criteria. And there's various ways to design this. Increasingly, RDD surveys are becoming of only cell phones. And in the United States, you can actually identify at a reasonably accurate level which telephone numbers belong to a cell phone by the second 3 digits was called the telephone number exchange. Or you can call both cell phones and landlines, depending on which population you're interested in. You might have more success by combining them. And you can what's often done is, particularly historically, when we didn't call cell phones, we only called landlines when pretty much all households had a landline. You might want to oversample for certain, particularly minority populations, so you can better ensure that you had a larger sample size to study disparities, for example. And so what you did there is you oversampled, meaning you sampled at a higher proportional level in neighborhoods, because you could tie the actual cell phone, the actual landline number into the geographic area where they lived based on the exchange and the area code, where there was a higher level of higher proportion of minority populations. And one of the issues with these kinds of surveys is that, to an extent, you can come up with a design where you can relatively reasonably control or have a good idea of what the probability of selection is. You can do essentially a complete random selection of telephone numbers where you're not oversampling, and so you're not inducing any overrepresentation of a particular sample population into your study. But there's a number of things that you can't control for that might affect somebody's probability of selection. And for cell phone surveys, most typically that is how many cell phones a person has that they receive calls on. So if somebody has two cell phones that they receive calls on, by virtue of just random dialing, they'll have twice the probability of being selected to participate in a study compared to somebody who only has one cell phone. And for landline surveys, you want to know how many landline phones are in the household and how many people inside the household meet the criteria, and then implement some kind of a selection approach within that household. And so there's some things out of the people who design and implement the surveys that are out of their control that actually impacts the probability of the sample member being selected. And that's important for you to know even if you're not part of designing the study, you just want to use the data. You need to understand what that design was, what those factors are, so that you can accurately account for that when you're doing your statistical analysis. What's good for the end user's perspective is that for particularly federal surveys and those produced by state agencies, they'll typically do the more difficult part of figuring out what the probability of selection was and producing variables for you to use in your analysis to account for that. And so they'll calculate what's called sampling weights that you most likely will want to use in your analysis. They'll specify a variable that identifies which cluster or which higher level unit a particular respondent belongs to, and which strata if they was a stratified design. So all that information should be in the data documentation. It's just up to you as the end user to be able to know enough what you need to look for, as well as where in the documentation you might find it. So I want to take the information that I've presented so far and sort of make it a little bit more concrete in terms of what the impact on the analysis might be and some of the things you have to consider. So if you're going to use these surveys that are designed to produce estimates of a particular population, general population or a state level population, you need to incorporate the sampling design, and if there's a weighting variable, you need to use that in your analysis. And most commonly, people use a design-based approach where they will essentially calculate weighted means or weighted proportions depending on what a particular sample member's sampling weight is. But you also need to be concerned not only with getting an unbiased estimate of a proportion or a prevalence estimate or an unbiased mean of whatever it is you're trying to measure. You also have to be concerned about how the sampling design impacts your estimate of the variance so that you get accurate confidence intervals and p-values and things like that. So most commonly people use a design-based approach, sometimes where they specify the model in the statistical software and you do your more sort of straightforward analysis in Stata or R, whatever program you might use. Increasingly, people are starting to use model-based approaches where they incorporate that information directly into a regression model. So as you read the documentation for the national and subnational surveys, you might see terms like design effect, effective sample size. And what a design effect is basically just the ratio of the variance of a particular estimate calculated incorporating the information that's available to you under the complex sampling design, meaning that you incorporate the clustering information, you incorporate the sampling weight information when you produce your estimate of the variance. the ratio of that to what the ratio is, assuming that the data were collected using your more traditional simple random sample. In most national surveys, this design effect is greater than 1, meaning the variance is larger in a complex sampling design than if they were from a simple random sample. And the effect of that is that the number of cases in the data set is not equal to your effective sample size. So for example, if you have a data set, you identify 1,000 people that is from the population that you're interested in, but because of clustering and because of using sampling weights in your analysis, you have a design effect of 2, which is not an uncommon design effect on the surveys that I've been part of designing. Usually the design effect is somewhere between 1.5, 1.4, and 2.5, sometimes a bit closer to 3. So 2 is not an unusual number. But your effective sample size then is 500, meaning that your variance estimate from the 1,000 people that you're actually analyzing in your data, by incorporating the information on the sampling design and using your sampling weights, you get the same precision of the estimates as you would under simple random sampling of only 500 people. And the effect of that is that your 95% confidence intervals will be roughly 40% larger or greater. And so just by having these more complex designs, you have typically a little bit less statistical precision. So the consequence of that is if you do want to produce estimates at a national level, state level, ignoring the sampling design and analysis can lead to a biased point estimate. So if you want to estimate the proportion of, say, young adults who have ever had a cancer diagnosis, you might come up with a much higher or much lower prevalence estimate than what the true value really is, because you're not incorporating that information. Or you might think that you have a much narrower confidence interval, you have much greater precision of your estimate than what you really do. Or if you're calculating p-values to do a hypothesis test, you'll likely have an increased type 1 error rate, meaning that you're going to reject the null hypothesis more often than the error level you set. And related to that, your confidence intervals are not going to be have the coverage probability that you specify in the analysis. So if you specify 95% confidence interval, the coverage probability, if you were to do a simulation study, would be likely lower than that. So I just want to summarize a bit about some of the advantages and disadvantages for using these types of secondary survey data for your analysis. The advantage is that they're often very large in terms of their sample size, but also large in terms of the types of topics they cover. And so they do measure a lot of different kinds of constructs, and that can be great. They typically have very, very good quality control in both their design and in the data collection, at least the ones from the CDC and the state level surveys that I've worked with and worked on. And they are designed to produce nationally and state representative data, because most of them are designed to track, monitor progress towards the Healthy People 2020 objectives. The disadvantages from the end user's perspective is that they have very complex designs, which means there are complexities you need to address at the analysis stage. Another disadvantage is that despite the fact that they're so large, because of some of the complexities, your actual effective sample size might not be as large as you want, or if you're studying a smaller subpopulation, even a national survey of, say, 80,000 people might not have even 1,000 people that belong to the population that you're interested in. So even though they collect data on a lot of different constructs, they may not have data on the specific variables you want to include in your analysis, but perhaps they have variables that are related to it, or they have collected data on the variables and the constructs that you're particularly interested in, but they may not have operationalized those measures exactly how you would want to do it if you were going to design the study from scratch. And that can be a common thing when you're talking about latent measures, meaning things that you can't directly observe, so things like anxiety, depression, financial stress, those kinds of things. because they collect data on so many variables, they try to make it as short as possible within any given construct. And so sometimes they'll include just a subset of items from a larger index or scale. Another disadvantage, depending on what you want to use the data for, is that it can be quite a long delay from the point at which the data are collected until it is available to the public. And if you're studying a relatively stable phenomenon, that may not be a problem. But if you're studying particularly something that's a problem for some risk behaviors, like tobacco use, that are sort of less stable over time, particularly for younger people, that can be a problem if you want to produce national estimates. Okay, so I'm going to switch gears and talk about web panels a little bit. Excuse me. And web panels are essentially just a collection of active survey respondents who have agreed to participate in periodic surveys conducted by a research organization or a survey research company. They can be general purpose, or what's sometimes called an omnibus panel, or they can be on specific topics. For example, the two examples I have here just happen to be two that I'm part of, which is to provide feedback on utility performance and utility needs in the community, as well as transportation issues. Or it can be, a web panel of physicians that provide care to cancer patients. Those exist. There can be web panels of patients. An omnibus panel is participants who have just agreed to participate in surveys on any topic. So it's not tied to a particular topic at the point at which they agree to be part of the panel, but the research organization that implements and designs the omnibus panel will collect a core set of questions, which are typically demographics, key health behaviors, key economic indicators for the participants. And the purpose of that is to identify patients that a client might be a researcher at an academic institution or another private organization who needs to access to a sample to collect data from. And so they want to be able to identify how many people who, say, young adults with a cancer diagnosis do we have in our panel, or how many young adults who currently use tobacco products do we have in our panel, so that they can give an estimate of what the maximum amount of sample size you might be able to get. And the way that these operate is that a client, say if I'm a researcher and I want to buy some sample, I would pay for both the data that I want to collect, the survey that I've designed, as well as some of the core variables that they already collect. Typically, you can buy those variables on the sample members on a variable per sample member basis. The sampling and recruitment tend to be is most often a little bit different from what I discussed for the national surveys. The most common recruitment and sampling approach for these web panels are what's called opt-in panels. An opt-in panel is essentially any person who meets the inclusion criteria can't participate, and there's not often a very systematic or way that researchers identify people to invite to participate. Sometimes participants happen to just come by an invitation on a website or someplace like that, and they say, hey, I'm kind of interested in this, I'd like to participate. So as a researcher, you typically don't have much information about how somebody came to be part of a research panel or a web panel. Another approach that's pretty common is what's called river sampling, where patients are invited when they go to a particular website. I'm sure most people have had the experience of going to a website. I have this when I go to the census website all the time, where a little box pops up and say, hey, we'd like to get some information from you when you're done using the website, or a box will pop up and say, hey, would you like to participate in this research panel? And that can be based on more complicated algorithms that incorporate some random start number and every person that goes to the website after that. You can incorporate information on IP addresses, which you may or may not be able to which you may be able to use to try to ensure geographic variability. And then increasingly, I think there's about 10 of these now, you have web panels that are designed a lot like the national surveys, but people are recruited to participate not in a one-off or a longitudinal survey for a specific purpose. They're recruited to participate in a panel on any survey that a client might want to do. And typical sampling approaches for that are random digit dialing or RDD. Some of these organizations will sample a list of addresses from the U.S. Postal Service list of addresses, and then go to those addresses, either mail a packet or show up in person and invite them to participate in the panel. So here you have a more complicated, more complex sampling approach and recruitment approach that really mirrors the national surveys we talked about before, but for a different purpose. The advantage of web panels is that you can obtain a relatively large sample size on a short turnaround time. We've collected data on 1,000 people, about 1,000 people in a 2-week period using web panels before. You can include your own content, unlike national surveys where you can only analyze data that they've collected that you likely had absolutely no input into how they operationalized or whether or not they included that content. Here you can design your own survey, and the research organization will program it and send it out for you, and then you get a data set at the end of it. You can include the core variables that they collect on their own research participants. Of course, you have to pay for it, but that means you might have time, since they've already provided that information previously, you might be able to produce a bit of a longer survey on the constructs that you're interested in. They're typically cheaper than most other data collection methods, at least if you're comparing it to if you were to design a survey study from scratch, design the survey, come up with the sampling plan, come up with recruiting materials, and actually selecting respondents and inviting them, following up, can be quite labor intensive. So here, somebody has already done that part for you. You just have to design and have them program the survey for you. There are some disadvantages that one of the concerns that people have with some of these web panels, particularly for the opt-in and river sampling, where people aren't, we have very little information on who these people might be or whether they're professional sort of survey participants who just are who answer a lot of surveys for no other reason. The incentive is what's called satisficing. And satisficing is essentially people who go through a survey very fast without a lot of consideration for what the answers are. They just want to complete the process of conducting the survey so they can get their incentive. And data quality might suffer as a result of that. In my particular field, the research I've seen on that suggests that that's not a huge issue for these web panels. I tend to use the web panels in the last category that sort of mirror the approach to sampling and recruitment that the national surveys do. And perhaps on average, they're a bit higher or better data quality than your random opt-in panel, but I'm not sure. For some of these, representatives is a concern. For the national surveys, you were very careful in your design and being able to estimate a probability of selection for a sample member that participated. For opt-in and river sampling, likely you don't have that information. You can do some calibration of your sample to census numbers, and sometimes that works well, sometimes it doesn't. But representativeness tends to be a concern because you do lack some of that information about how somebody came to end up in a web panel. Increasingly less so, coverage has been a concern for the approaches that use a non-probability sampling approach. It used to be that we had this digital divide in the US where more educated and higher income or higher SES people had access to the internet on a regular basis, and lower SES and lower educated people did not, which was of course correlated with things like race, ethnicity, geographic location, things like that, which could produce biased estimate if the cancer area you're studying were related to those variables. Now we have a different type of digital divide where the vast majority of people over 80%, close to 90% in some subpopulation, over 90% in some subpopulations, are connected to the internet on a regular basis, but the quality of that connection can differ. So now higher SES people tend to have broadband in their homes. They have multiple devices they can access the internet through. They can access the internet in multiple locations, work, library if they go there, at home, whereas lower SES folks sometimes are dependent on accessing it only at their work, or they go to the library, or they might rely only on their smartphones to access the internet. And so there's this divide in the quality, or not quality, but in the sort of quantity, the quality of their connectivity. But the reason we're becoming much better at designing surveys that work on smartphones, following up with people that don't respond right away, and so some of those concerns are starting to be mitigated a little bit. Another historic concern for these types of web panels is that they tend to have very, very low response rates. So you have a response rate, but the proportion of people who are sampled who actually end up in the panel, and among those that are in the panel that are invited to take your particular survey, what proportion actually complete your survey. So if you multiply those two, you get a response rate for your particular survey, and that tends to be quite low. I tend not to be, I'm always concerned about response rate, but if you look at particular random digit dialing surveys, in the last several years, the response rates there have gone down tremendously as well, and it's quite typical to have response rates of 20% or less for those types of known probability-based surveys. And the research we've done so far suggests that the data quality and the sample representativeness there tend to be quite good despite the lower response rates. And so people are working on how to sort of use similar methods to evaluate and address that for web panels as well. Okay, let me make sure that we're not going over on time. Okay, we have a few minutes. So I just want to go through how you might go about looking for the information you need to be able to do your analysis using the National Health Interviews Survey. And I chose the National Health Interviews Survey partly because I've used it quite a bit, but also because I think their documentation is very, very good and more manageable than a typical national or even a state survey. And so essentially what you're going to see here is a bunch of screenshots from their websites and from their documentations of federal agencies, so it's publicly available. And so I'm not picking any copyright laws here. So first you would go to the NHIS website, and immediately you can see if you want to study and download the most recent data. We're now midway through 2019, and the 2018 data have not yet been released. And so you'd have to go down to 2017 to actually access data to analyze. So already we're a year and a half after you, on a year and a half delay for analyzing data that have been collected. So you would find the data documentation or the public use data file description for the year that you want to do, because they might make some small changes on a year-by-year basis, typically to the content, not so much to the design. And you can see it's a relatively large document. It's 107 pages, which is not, it's actually on the shorter side of these kinds of data release documents that I've seen or been part of creating. And so then you go to the table of contents that you want to make, and so you want to learn about what their sampling design was. So you know whether or not they did an area probability sample. Is there clustering I have to worry about? Is the probability of being included in the sample different, or is it unequal among the sample members? So I have to worry about sampling weights. And then you want to read about the interviewing procedure if you want to publish the data. Those are things you're going to have to report in your a journal article. And you can see there's information on the various data files that are there. Remember, NHIS is a household survey, so some data are collected on a family-wide basis. Some is collected only from adults, some are collected only among children. So you find the section on weighting, and you can see in the first paragraph, it already says that the data are collected so that everyone has a no non-zero probability of selection, but that these probabilities actually do differ. So you do have to worry about using a sampling weight. And depending on which data set you want to use, what you want to do, make inference about the family, what do you want to make inference about the children who live in the household or the adults, you have to find the correct weight. And so they say towards the bottom of the page, there's two sets of weights provided. There's the final annual weight, and in parentheses is actually a variable name, even though I think they should write variable name is WTFA, which is not very descriptive, but it is the acronym for weight final annual. And there's a short description on that. And there's also an interim file that does not have a calibration adjustment to adjust for non-response and to make sure the sample characteristics are like the census. Okay, so you can see this is just the next page where they have that description for if you want to analyze the children in the data set, then you use the sample child weight. If you want to analyze only adults, you would want to analyze the sampled adult weight. Or if you want to produce household estimates, then you do the final. So there's a number of different weights. So it's on you as the end user to figure out which weight is the correct one for your particular analysis so you don't incorporate the wrong information. Then you go down to the variance estimation section to read about how did the sampling design and sampling approach impact how you handle your, whether or not you need to incorporate that in your analysis. And the description is pretty clear that the use of standard statistical procedures are based on the assumption of an SRS, and that's going to produce most of the time incorrect estimates for variances and standard errors if you were to treat these data as a simple random sample. So they have a pretty good description of what that implication of that is for if you're going to use the NHIS. But you also need to know what are the variables I need to use and how am I going to use these variables in my analysis. What do I need to do? And so you need to go a little farther down in the document, so it's not all in one place. And you can find the variables you need. So they have pstrat, which is a variable name for the stratum that a respondent belongs to. They have the PPSU, or PSU stands for primary sampling unit, so that's the higher level unit that they selected, which you need to specify your analysis to get accurate variance. And then you have the weighting variable, which here is listed as the final annual person file weight. But like I showed you a couple of pages before, depending on which population you want to make inference or what unit you want to make inference about, you might need to use a different weight. And so you have to process the information in the data document and the data dictionary to figure out what is the correct variables you need to incorporate in your analysis to get unbiased estimates of both the variance and the point estimates. And a lot of the national data sets have examples of how to specify this in your analysis. And I'm only showing SAS and R because among the investigators I work with, those are typically the softwares we use, but they also have for Stata and SPSS. And so this is an example of the syntax you want to use. The bolded numbers are the variable names. And so once you figure out and you process the data documentation, you need to see what are the variables, what are the measures they have, do they have measures on the constructs that I want to do, and what are those variable names called in the data set. And so then you go to the data dictionary or the survey to find that information, and you can see that they have multiple different surveys or data dictionaries depending on what whether or not they're interviewing the child, or if the data is collected from the child or about the child, from the adult, or if it's a family level variable. So say you want to estimate the proportion of young adults who have had ever been diagnosed with cancer or been told they have a malignancy. You have to find have you ever been told by a doctor or health professional that you have cancer? That's the question that they asked during the interview. The variable name is, which you can see on the top line there, is CANEV, CANEV, or which is short for cancer ever. The universe is what population they're collecting this data on, which is right below the numbered response categories. In this case, is all adults 18 years and older. And maybe you want to know excuse me, what age say the average age or the median age of cancer diagnosis are for young adults. So you want to find the age variable of the diagnosis. So how old were you when you were first diagnosed? And that's an open-ended question, so they provide the age without being read response categories. And the name of that variable, as you can see from the top line, is can age 1. So they're not very intuitive names. Once you get to know the data set a bit, you can start to sort of guess a little bit about what the names are, because they tend to be pretty consistent in their naming, even though it's not so descriptive. And that's collected by adults. You can see the line that says universe sex, all adults 18 plus who have ever been told they have cancer. And once you figure all that out, you want to go to the actual site where the data are available. And here you can see that you have, towards the bottom here, you'd want to pick the sample adult file, because from the data dictionary you saw that those particular variables were collected from a sample of adults 18 plus old, which happens to be in the sample adult file. So you might want to download the CSV data. And what's great for this survey is that they have SAS statements, SPSS statements, and status statements that will extract the data for you and read in the value labels and the variable labels and those kinds of things to produce a much tidier data set than if you were going to work from scratch. I tend to use R, so I have to do a lot of that work myself, but once you do it a few times, you get pretty good at picking out the variables that you need and assigning the labels in a descriptive way that works for you and your research questions. Okay, so that's essentially how you would navigate a national data set. There's a lot of information you have to consider. You need to know the sampling design. You need to know whether or not you're dealing with clustering, how many levels of clustering, what the variable names are for the clusters, how to find the information on the particular variables that you want to analyze. Okay, so that was it. Any questions, either here or remotely? Okay, thank you very much.